Hey everyone, Cozy Azeroth here, aka Zachary Fruling. Today I'm going to continue my foray into Beginner's Basic for the Texas Instruments TI-99 4A home computer, and we're up to Chapter 5, Computer Graphics, which, if memory serves, this was my favorite chapter of this book on this system when I was a kid. So without further ado, let's dive in. This chapter continues developing programs that demonstrate the graphics capabilities of your computer. The programs deal with the use of color, animation, and the generation of your own graphics characters on the screen. The intent in this chapter is to give you some hints and examples that will help you expand your enjoyment and use of your computer. As you begin to develop your own graphics applications, you may want to refer to this material for ideas on how to approach the use of color and graphics. In time, you'll discover other ways to create specific programs and simulations. But for now, the programs that are given here will demonstrate several techniques you'll enjoy using. Blocks of color. In previous chapters, we've experimented with several programs that placed color lines or squares on the screen. The program below shows you how to create larger blocks of color. Okay, let's go ahead and type this in. So let's get to TI Basic. I'm using the classic 99 emulator, by the way. So 10 input, color code. Let's make sure we get this right. Question, I always put a space there. Colon C for the color. Okay. 20. If C is less than 1, then 10. This is just sort of error checking. 30. If C, I think it was greater than 16. Yep, greater than 16. Then 10, I think. Yep. 40, call clear. $50, call color 2, C, C. 2, C, C. Okay. 60 for I equals 1 to 4. I equals 1 to 4. 70, I have a few VCHAR statements. 70, call VCHAR. Oops. Oh no, what's happening here? I don't know what's happened. Alright, we're gonna... Let's restart. Sorry about that. I don't know what happened there. A button got stuck on the emulator, and I'm sure it is not desktop. Let's see. Let's get the emulator started back up here. I don't know what happened there. I thought a button was stuck down or something. 1. Okay, let's try this again. 10. Sorry about that. Input color code. Color code. C. 20. If C is less than 1, then 10. 30. If C is greater than 16, then 10. 40 was call clear. Yep. 50, call color. 2, C, C. Basically, character group 2, foreground and background color are both C, whatever color we enter, color number we enter. 60 for I equals 1 to 4. I equals 1 to 4. 70, and here's where we were. Our VCHAR statements. Call VCHAR. 2. I plus 2. 42 and 4. 80, call VCHAR. 19, I plus 2. This is row number and column number, essentially. 19, I plus 2, 42, and 4. Okay. 9b, call VCHAR. 2, I plus 24. I plus 24. And same thing, 42 and 4. 100, call VCHAR. 19, I plus 24. I plus 24, comma 42, comma 4. Basically, row number 19, column number I plus 24, character number 42, which is an asterisk, and 4 repetitions vertically. Okay, then we have 110, call VCHAR. 12, I plus 13. I plus 13, 42, comma 4. 120, next I. 130, input, press enter key. I think it had a colon and key. Key string. 140, go to 10. Okay, let's see what the comments say here. Check for valid color code. That's what lines 20 and 30 do. Set the color, foreground and background color for the same character group. Wait here, makes just wait to press the enter key. Each call VCHAR places a vertical strip of color on the screen. Okay. First, the program stops and asks you to input a color code. See Appendix C for the list of colors that correspond to the valid color codes, 1 through 16. When you enter a code, the screen clears, the blocks of color are displayed, and the program waits for you to press a key before continuing. Notice the special use of the input statement in line 130. We are just using input to stop the program until we are ready to go on. Now clear the screen and run the program. Okay, call clear, run. Okay, color code. I don't know, let's do 14, magenta. There we go. The color blocks here. Press enter key. Color code. We can do all the colors if you want. Why not? Let's. 1 is transparent. 2 is black, I think. Right. Color code 3, I think, is some sort of green. Yep. 4 is the same color as the background color, so we won't actually see anything with 4. 5, some shade of blue, bluish. 6, slightly different shade of blue. 7, I think, is a red. 8, cyan. 9, I think, is another red. 10, different red. 11 is a yellow, I think. 12, slightly lighter yellow. 13 is a green. 14 is magenta. 15 is gray. And 16 is white, I think. There we go. Okay, and we can check our error checking. So if we end up with a 0, right, it doesn't like that because it's less than 1. If we do 17, same thing, it doesn't like that because it's greater than 16. And that is our color square program. First, you'll see color code, flashing cursor. We did see that. Remember that color code 1 is transparent and code 4 is the screen color in the run mode. So let's enter 7. Dark red is our first color code. When you press enter, you'll see this. 5 dark red blocks, light green screen. Press enter when you're ready to go on for a new color. Experiment with several colors. We just did that. Find the ones that produce clear, sharp images against the normal color of the screen. Can you see how this technique could be used to create checkerboard patterns from the board area for a game like tic-tac-toe? Each block in this program is 4, quote, characters wide and 4, quote, characters high. If you'd like to see the characters, press clear to stop the program, and that gets us to where we were. You can see that the characters were really just asterisks with the same foreground color and background color. The call screen statement. So far, the color of the screen in the run mode has always been light green. Suppose, however, that we would prefer a different color as a background for our color design. Easy. All we have to do is add a simple statement that changes the run mode screen color. Call screen 11. Color code for screen color we want enclosed in parentheses. Let's edit the color block program we just entered so that we can use a different screen color as a background color for our blocks. Enter these lines. Okay, let's clear the screen. Let's list out the program that's already there. And after that lists out, we'll make the additions the book recommends here. So 32 input screen color, and we'll call that A. So 32 input screen color, we'll call that A. Okay, 33, if A is less than 1, then 32. A is less than 1, then 32. 34, if A is greater than 16, then 32. Of course, you normally number program lines by 10 in BASIC, but we're inserting some lines between the extant lines of the program here. And 45, call screen A. Okay, now let's list out the new program. See our new lines inserted. Okay, so just for people just tuning in, I see a couple of folks tuning in. We've got line 10, input the color code and call that C. And then lines 20 and 30 just error check to make sure that the value is between 1 and 16. Then we're going to input the screen color. Same thing, error check to make sure that's between 1 and 16. Line 40 clears the screen. Line 45 changes the screen color. Line 50 defines the color of the character group 2, and we'll call that C with the same foreground and background color. 60 is just a loop, I equals 1 to 4, and then we loop through line 70 through 110, and each of those prints a vertical line on the screen, and then each loop bumps them over to make little squares. Line 130 is just a holding, put you in a holding pattern until you press the enter key, and then we go back to the beginning of the program. So let's run it. Color code. Let's do, I don't know, how about magenta? Screen color, let's do, how about black? There we go. So we end up with a black screen. Oh, now we can't see our, okay, it's asking us for, sorry about that, the text is the wrong color. So let's, it was the color of the squares first, I think. So let's do, I don't know, red squares and a white background. There we go. Now we should be able to see our text. Press the enter key, color code. Oh, I don't know, how about, I used to like doing white things on a green background, so 6 white squares on a dark green background. It's a nice looking color palette. We could do like I think line number 12 is kind of a light yellow on a, let's do a blue background, maybe like, I think 6 is a blue color of some sort, bluish, purplish blue. There we go. So you get the idea. Let's end the program, and let's see when you end the program, it takes, you can see those color squares were made up of lines of asterisks with the same foreground and background color. Okay, so let's at least look at our bubbles here that explain what we just did. Input the screen color code, check for a valid code, and change the screen color from light green to the color you input. Now run the program again. This time you'll be asked to enter 2 color codes. The first code determines the color of the blocks, the second sets the color of the screen. Experiment, we just did that, with different color combinations. Which give you the sharpest, clearest design? Which are most pleasing in an artistic sense? Then try changing the block design produced by the program. For example, can you make the blocks rectangular? Oh, we probably can. Let's see. Why don't we list out the program. It's just a little challenge to see if we can make the blocks rectangular. Since we're drawing vertical lines and a certain number of them, why don't we change line 60 for I equals 1 to 2. I think this should make small rectangles on the screen. Color code, let's do, I don't know, how about dark green square rectangles now on a cyan background. There we go. And now they're rectangles instead of squares. So basically we printed, rather than looping 4 times, we looped twice to create 2 rows of asterisks instead of 4 for each square. Okay. Patterns. The 2 programs we'll develop next continue our exploration of computer graphics by showing how to construct patterns out of standard characters. The statements and functions used in the program are elements of BASIC you already know. However, you may see some new applications of these features. Excuse me 1 second, I just have a little pop-up I want to check. So I just bought a cross-stitch pattern, that's cool. Rectangles and squares. The first program allows you to place a rectangle or square of standard characters on the screen. Instead of using call HCHAR or call VCHAR and identifying the character by its character code, we'll assign a character to a string variable from the keyboard. Try these examples in the immediate mode. Okay. Let's just get a new instance of TI Basic here. Okay, let a string equal, what was it? Just an asterisk. Okay. Print the asterisk. Okay, it prints out the asterisk. Okay, print a string, semicolon a string. Semicolon a string. So 2 asterisks. Okay. Print a string, then it was semicolon tab 10, and a semicolon and a string again. 2 asterisks separated by some distance. Try a few more immediate mode experiments on your own. For example, what would happen if you redefine a string as 3 asterisks or as 2 parentheses? Try it and see what results. Okay. Well, let a string equals 3 asterisks this time. Boom, boom, boom. Print a string, semicolon a string. 6 in a row, just connects them together. And print a string, semicolon tab 10. Oops, typos, sorry about that. A string. There we go. Get the idea, I think. Okay, if you need to review the tab function and the print separator, see Chapter 3, page 57. That's okay. You can see my previous video on Chapter 3 if you want to see that. This method is convenient if you want to print only a short line of characters, but what if you want to print a long line or vary the line length or character the program prints? Input statements and a for next loop will solve the problem. Type new, then enter this program. Okay, 20 input character. And we call that a string. Oops, colon a string. 40, excuse me, input width. And we'll call that W. I always put a space after the question mark in input statements in TI Basic. 60, call clear. 80 for x equals 1 to w. X equals 1 to w. 100, print a string and a semicolon. a string and a semicolon. 120, next x. And 140 end. Okay, so before we run it, let's look at the explanation bubbles. Accept a character, accept number of characters to be printed, semicolon. When you run the program, you'll first be asked to input the character you want to use. Just type the character and press enter. Then you'll be asked for the quote width, or the number of characters in the line you want to print. Type in the number and press enter to continue the program. Let's say that you entered an asterisk as the character and 28 the width. The screen will look something like this. Okay, let's run it. Asterisk. And what did it say? 28 is the width. 28. Okay. The screen will look something like this. Note that the semicolon in line 100 causes the characters to be printed in an unbroken row. Run the program a few times, entering different characters and lengths. Then let's try adding some program lines that will allow us to make rectangles and squares of characters. Okay, so let's run. I don't know, how about Z for my first name, Zachary, and width. And I'm 47 years old now, so let's say 47. There we go, there's 47 Z's in a row, and of course after 28 it moves down to the next line and continues writing out the line. Okay. Enter these new lines. Let's list out the program before we do that. I always like to list the program so I can see where we're making additions. 40, input size, width, comma, height. Okay. 40, input width, comma, height. Okay. And we call that W and H. W, comma, H. 70 for Y equals 1 to H. $130 print. 135 next Y. And 140 go to 40. Okay. Let's run the program. Actually, let's see what it says. There are a couple of items that need to be explained about these lines. First, notice in line 40 that we are using one input statement to assign values to two variables. When you input the width and height, you'll need to use this form. The number of characters you want in each row, comma, the number of rows that you want. Okay. Second, line 70 and 135 set up a loop on the variable y. Your original x loop is now nested inside the y loop. Finally, line 130 prints an empty line. This line is needed to clear away the semicolon in line 100 so that a new row will begin the next time the program loops through the y loop. As you've seen already, the semicolon causes the characters to be printed on the same line throughout the loop on X. Before we list the program to see the changes, let's add a few more lines. We can use if-then statements to build in some tests. Okay. 25 if a string equals XX, then 150. $45 if width plus height equals 0, then 20. Oh, excuse me, then 20. So 40, let me retype that. 45 if width plus height equals 0, then 20, not 120. I'll list out the program again here in a minute. And 150 ends. Okay, if the character is XX, stop the program. If both width and height are 0, ask for a new character. Okay. Here's what these tests provide. Line 25 gives you a handy way to stop the program by pressing the X key twice and then pressing enter when you're asked for a character input. If you want to experiment with a different character, all you have to do is enter 00 as size inputs. The test in line 45 then sends you back to line 20 to input a new character. Now clear the screen and list the program. Okay, call clear. And list. Should have everything correct here. Okay, so if a string is XX, then stop. If width and height are both 0, get new character input. Print a line of characters. Start a new line, return for new size inputs. Okay, clear the screen and run the program. For this example, enter asterisk when the program asks character. Then enter 8,5 when you're asked for width and height. Okay, run character, so asterisk, and enter 8,5. Okay, we get a rectangle of 8 by 5. Okay, we can do it again. Let's do it with Z. Oh, actually, just let's see, 0, 0 for a new character, right? So let's go Z, and let's do 10 by 15. Oops, 10, 15. Had a typo there. That was a 10 by 15 rectangle made up of Z's. Okay, 8 by 5 rectangle of asterisks and waiting for new values. Next, enter the same value for both width and height, such as 8, 8 or 5, 5. Okay, let's do it. Let's enter 0, 0, and we'll go back to an asterisk. 8, 8. Okay, 8 by 8, 5, 5. It's a little obvious, but let's do it since it's recommended by the manual. With these inputs, the program will create a square rather than a rectangle. Perhaps a flowchart will help to describe how the program works. The following diagram doesn't show the whole program in detail. It covers only the parts that relate to program control by input values. So let's zoom out a little bit so we can see the whole flowchart. Uh-oh, lost our place here. There we go. So line 20, input a character. Line 25 is the character in XX. If yes, then stop. Go to line 150. If it's no, then input the size, width, and height. Is the width plus height equal to 0? If yes, then input the character again. If no, clear the screen, display a rectangle or square, and return to line 40, which asks for the input size, again, width and height. Okay. Wow, every time I zoom in, I lose my place here. There we go. Experiment with the program. Try entering the control values, character input equals XX, width and height both equal 0, to see how the program reacts. Vary the width and height so that the display fills the screen or makes only small, tall, thin bars and wide, flat strips. What happens if you enter a width greater than 28 or a height greater than 24? Try it and see what happens. Okay, let's try it. So width greater than 28. Let's do 44 by 10. You can see it's trying to extend the rectangle past the screen. In fact, it's a great way to make a little American flag. Check that. We can probably write a little program that builds an American flag very, very easily. That would be interesting. And now let's do a width of, I don't know, 10 and a height of 55. It's just going to keep scrolling up past the screen, I believe. Yep, it's just going to keep printing. Up we go. Eventually we'll run out of lines here. There we go. Okay. Let's see. Can you add color to this program? I bet you we could. Let's see here. List. We're just going to assume we're going to input asterisks. So let's say, where should we enter the, so line 65, call color, and let's say we want to add, I don't know, white asterisks on a magenta background. I think that will do the trick. So let's just do 6 and 6. Yep, there we go. White asterisks. And notice that the comma is in the same character group as the asterisk, hence the comma is getting the color adjustment as well. Okay. Holes. Let's expand the rectangles and squares program one more time. These new lines will create rectangles or squares with a random sprinkling of holes or blank spaces in the display field. Enter the following lines. Okay, we need to eliminate our color addition here, which was line 65. Okay, so I just deleted line 65. 15 randomize. 85 if integer of 2 times R&D equals 0, then 100. Okay, print, and then a blank space. Okay, is that line 90? Yeah. 90, print, a space. 95, go to 120. Okay, I'm going to clear the screen. Let's list out our modified program. Take a couple sips of my coffee. Okay, so integer 2 times R&D produces a 0 or a 1. Clear the screen and list the changed program so that we can discuss the effect of these additions. Okay. So if on line 85, if true, go to line 100 and print the character. If false, print a blank space on line 90. Skip line 100. 90, so after we print the space, it skips line 100. Okay. The test with the R&D function, line 85, causes a character to be printed whenever integer of 2 times R&D is equal to 0, a space when int of 2 times R&D is equal to 1. Thus, approximately half the time the program prints a character and half of the time a space. Run the program now and observe the kind of pattern that emerges. Okay, okay, character, let's do an asterisk again, just for consistency's sake. And let's do, I don't know, 20 by 20. Oh yeah, so we should be getting so why are we not getting we need to check our program here. It must be a mistake. List. Must have a typo. So 15 randomized, 20 input character a string, yep. 25, yep, that line looks right. 40 input size, width and height. I forgot size, but width and height, that's fine. If width and height is greater than 0, then 20. 60, call clear. 70 for y equals 1 to h. 80 for x equals 1 to w. 85 here, there might be a mistake here. If integer of 2 times R&D equals 0, then 100. 90, print the space. 95, go to 120, yep. 100, print a string. Okay. 120, next x. 130, print. 135, next y. 140, go to 40, and 150, end. You'll be able to see the holes better when making a character into a color block. Add these lines into the program. Okay. 10, input color. And we'll call that C. 45. If width plus height equals 0, then 10. And 50, call color 3, comma C, comma C. C. Okay. Note that when the program asks color, type and enter a color code from 1 to 16. Notice that to see the character in color, you'll have to enter a character input from set number 3. 0, 1, 2, 3, 4, 5, 6, and 7 are the characters in this set. Okay, let's run it. Color, I don't know, 7, oop, sorry. There we go, 7. Character, asterisk, 20 by 20. Strange, it's almost getting like it's getting a line break where there shouldn't be. Let's stop the program, see if we can find it really quickly. If not, we'll move on. Color, let's try 7. Character, let's do 5. 20 by 20. It's so weird because rather than continuing to draw the width and the height, it's getting a line break in there, and I can't figure out why. Is there a typo in the original program? Let's check this out again. So 70 for y equals 1 to h. 80 for x equals 1 to w. Okay. It's very strange. I wonder if there's a typo in the original program. Okay, let's move on. Animation. So let's get rid of this new. Animation. Animation is the illusion of movement. In order to achieve this illusion in your graphics programs, it's necessary to keep changing your characters or sets of characters. The following programs demonstrate some of the techniques used to create flashing and moving graphics on the screen. Flashing letters. One way to create a flashing graphic is to print a character or a set of characters, delay the program, clear the screen, delay the program again, and then repeat the process. The clearing of the screen and the delays have the effect of turning the character on and off, making it appear to flash. Let's try a program that flashes the letter A in the center of the screen. Okay, so 10, call VCHAR. "12, 16, 65. That's row 12, column 16, character code 65. 20 for delay equals 1 to 200. "30, next delay. "40, call clear. "50 for delay equals 1 to 100. "60, next delay. "70, go to 10. Okay. Run. The letter A just should flash on the screen now. We'll stop the program. prints the character on the screen, then there's a 200 count delay, clears the screen, there's a 100 count delay, and then go back to line 10, prints the character again. So the character is on the screen a little longer than it's off the screen. Okay, so to explain, 65 is the numeric code for A. Lines 20 and 30 are a pause after printing. Lines 50 and 60 are a delay after clearing, and 70 repeats, goes back to line 10. Now clear the screen and run the program. Oh yeah, we didn't clear the screen. So call, clear, run, and here we go. Flashing A. The letter A flashes on and off the screen. I love this little flashing depiction of flashing here. Okay. Another way to simulate flashing is to replace one character with another in the same spot on the screen. Let's revise our program so it alternately flashes A and B. We can do this easily by entering a new line 40. So let's list out the program. So 40, call VCHAR, 12, 16, 66. 12, 16, 66. Same position and the code for B. Since we're replacing A with B, we don't have to clear the screen between printing the characters. However, we may want to add a call clear at the beginning of the program, so enter this line, 5 call clear. Run the program. Do A and B appear to flash alternately on the screen? You may want to increase the time delay in line 50 so that A and B will each stay on the screen the same length of time. Okay, let's do that. We'll run it and then we'll change the delay. So B doesn't stay on the screen as long, but it is flashing between them. So let's list out the program and edit the time delay in line 50. So 50 for delay equals 1 to same amount, 200. Run. Now A and B stay on the screen the same amount of time. Nice. From flashing characters to flashing color squares is an easy step, so we'll examine next a program that places a flashing color square on the screen. Flashing color squares. With this program, we want to create a color square that flashes on the screen. We'll write the program so that we can input the color we want, and we'll use character 42, the asterisk, and character set 2 to make our square. Here's the program. Okay, let's start typing, so new, 10 call clear, the beginning of almost every TI basic program, 20 input color code, we'll call that X. 30 call clear. Call color 2, X, X. 2, X, X. 50 call VCHAR. 12, 16, and 42. 12, 16, 42. 60 for delay equals 1 to 200. 70 is just next delay. Time delay loop. 80 call clear. 90 for delay equals 1 to 200. 100, next delay. And 110, go to 40. Let's see what the explanation bubbles say. So accept color code 1 through 16. Define line 40, define the color for the character set 2, which contains the asterisk, and make foreground and background the same color. Line 50 prints the square of color. Line 80 clears the screen, and line 110 repeats, goes back to line 40. Okay, let's see what does it say to run the program. Now run the program. First it asks color code and waits for you to input a valid color. The codes are 1 through 16. Remember, however, that 1 is transparent and code 4 is the normal screen color in the run mode. Squares of these colors will not show up on the screen. When you type in a color code and press enter, you'll see the square flashing near the center of the screen. Okay, well, let's do that. Run. Color code. I don't know. How about I always go for magenta. It's just like one of my favorite colors. You know, I wonder if people have other than me, have their favorite TI-99 color code. 14 is one of my favorites. Color code, and we get a blinking square that is magenta in the middle of the screen. And if we end the program and run it again, now we could do a, I don't know, how about a white square? There we go. And one more time. I think 11 is kind of a dark yellow and kind of a darkish yellow color blinking in the middle of the screen. Next, let's change the program to create 2 color squares that alternately flash on the screen. To do so, we'll need to input 2 color codes. So enter these lines first. 20, input color 1, color 1, and we'll call that X. Okay, and 25, input color 2. We'll call that Y. Now we'll replace our original line 80 with 2 new lines to set the color and display the second square. So 80, call CHAR. Oh, I'm sorry, call color. I'm ahead of myself there. Call color. 2, Y, Y. And 85, call CHAR. This is 12, 16, 42. Let's review these changes by listing the program. Clear the screen, then type list and press enter. Okay, call clear list. So you can see some minor things they did differently. Like rather than running color 1 together, I put a space there and a space after the question mark. I like that kind of convention. Okay. So lines 40 through 60, first color squares on the screen, and lines 80 through 100, the second color squares on the screen, and line 110 repeats back to line 40. Select your 2 colors and run the program. Type in the color codes as the program asks for them. The 2 color squares will alternately flash on the screen. That's fun. So let's do the same colors we just chose. Do magenta and white. There we go. Now we've got a blinking purple or magenta and white square. Let's do it again. More colors, because colors are fun. Let's do, how about green, like a dark green and a medium yellow. There we go. Experiment with several color combinations to find those that give good contrast. Here are a few examples to try. Okay, let's do this. 6 and 5. 6 and 5. So not great contrast, I think. You know, unless you're going for 2 different colors of blue. But 11 and 14. 11 and 14. There you go, that's a little bit more contrast. Good color contrast. 14 and 16. 14, 16, magenta and white. Okay, and 9 and 11. 9, 11. Not too bad. A reddish color and a yellowish color. Moving color squares. With just a few simple changes in the previous program, we can make the color squares move across the screen as they flash. Add these lines. 35 for I equals 3 to 28. For I equals 3 to 28. Okay, 50, call VCHAR. VCHAR. 12, comma I, comma 42. Okay. 85, call VCHAR. And 12, comma I, comma 42. Oops. So this is row number 12, column number I, which is being incremented as the loop progresses, and character number 42, the asterisk. 105, call clear. .110, next I. End of the loop. And 120, go to 10. Alright, now I think it said to list out the program. Now list the program to review the changes. So clear the screen. List. Let's make sure we're in the right ballpark here. Okay, looks pretty good, I think. I don't think I made any mistakes. Got Y and I there. At a glance, it looks pretty good. Okay. When you've checked the program for accuracy, run it. Starting at column 3, the squares flash and travel across the screen, ending at column 28. Then the screen clears and the program asks you for new color inputs. Okay, run. Color 1. I don't know. How about a dark green and a magenta? It'll kind of walk across the screen. There we go. Slowly. Let's wait for it to get all the way to the end. It'll take a second. We're going to speed this up here in just a minute. That's one thing I love about the TI-99. It's just so easy to make colorful, cool things happen on the screen. It's almost easier to make cool things happen on the screen than in modern programming languages. Like a little tiny inchworm inching its way across the screen. Okay. I think let's end the program. We get the idea. Okay, experiment. If you want to speed up the flashing, shorten the time delay loops in lines 60 and 90. For a challenge, you might like to make the program flash 3 color squares. How would you do it? All right, well, let's list out the program. So shorten the time delay loops. Yeah. So 60, I think it said lines 60 and 90, is that right? Yep. So 60 for delay equals 1 to 50, and 90 for delay equals 1 to 50. And that should speed up the program significantly here. So, I don't know, color codes, how about cyan and a yellow? There you go, a little faster. We'll see if we can get a third square in there in a minute. It's been a while since I've written anything in BASIC, so we'll see. List. How would we get a third color square in there? Okay. So let's see. Let's do, we need another color, right? So let's do line 27, input color 3, and we'll call that Z. Oh, I forgot a end quote there. 27 input color 3 question mark. Yeah, colon Z. It's funny that I hear that beep even after all these years. As a little kid, it still stresses me. Like, what did I do wrong? So, yeah, instant notification. I've made a mistake. Okay. Let's see here. So looking at the program, we're inside the line 35 through 110. That's the loop, and we print the. Basically, just need to add. Where can we insert this here? It looks like, let's call it line 101. Call color 2, Z, Z. And we're trying to squeeze in a couple lines here. Then we need another delay. Actually, no, we print the character on the screen. So call BCHAR 12, I, 42. So row 12, column I, character number 42. Now we need to create a delay, 103 for delay equals 1 to 50. We'll use the same value that we changed. It was originally 200, but we changed it to be 50. And 104 next delay. And that should allow us to rotate between 3 character blocks before the character changes position on the screen. So let's run it. So color 1, how about a white, and how about a nice happy yellow, and a nice contrasting magenta. Yep, so 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, clear the screen, 1, 2, 3, so on and so forth. And then when it reaches the end, we'll do it twice, just for fun, frankly. Not trying to rush, trying to have some fun. Hey, thanks for everyone tuning in. I see a couple people watching. I don't know. Are you guys watching? Does anyone have any experience with the Texas Instruments TI-99 4A home computer? It was my favorite old computer system from when I was a kid. So let's do totally different colors this time. Let's do like a blue and like a dark green, and how about black? There we go. Funny, I still have the color codes basically memorized from when I was a kid. I wrote so many programs in BASIC when I was a kid. So when it reaches the end of the screen, we'll break the program and continue with the chapter. This is by far my favorite chapter of this book. Cool things on the screen. I still like putting pretty cool things on the screen. Just finished working on a retro game and putting cool things on the screen. Okay. By this time, you've seen several examples of the kind of graphics you can create with the standard characters of your computer. Next, we'll show you how to develop characters of your own. The call CHAR statement. The call CHAR statement gives you the capability of creating your own screen characters. In our first program, we'll redefine some of the standard characters. Before we redefine a character, however, we must look at the way a character is represented on the screen. Each printing position on the screen is made up of 64 tiny dots. The dots are, funny, we'd call them pixels now. The dots are arranged in 8 rows of 8 dots each. Each row is partitioned into 2 blocks of 4 dots each. The diagram below shows how an 8 by 8 grid of dots would look if it were greatly enlarged. Okay. 8 left blocks and 8 right blocks, total of 16 blocks. Each block is 4 dots wide and 1 dot high. Okay, any row. Boom, 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 boom. A character on the screen, either a standard character or the one you invent, is formed by the dots within the 8 by 8 grid. By turning some dots on and leaving others off, a character is created. Leaving all the dots off creates the space character, character code 32 for example. Turning all the dots on produces a solid spot on the screen. Okay, so yep, all turned off, invisible, all turned on, visible. All the standard characters are automatically set so that they turn on the appropriate dots to produce the images you have seen. To create a new character, we must tell the computer which dots to turn on or leave off in each of the 16 blocks within the printing region that contains the character. In your computer, a shorthand system is used to specify which dots are on or off within a particular block. The table that follows contains all the possible on-off conditions for the dots within a given block and the shorthand notation for each condition. And this was one of my favorite parts of this old book. I mean, I was learning hexadecimal when I was like 4 years old. It's a really useful book. So you can see here, this is basically binary here, of course. So we've got all dots off, that's just 0, 0, 0, 0, or 0 in binary, and the shorthand is just 0 in hexadecimal. 0, 0, 0, 1, that's 1 in binary, and that is 1 in hexadecimal. And so if you kind of look at these, each row of 4 here, the one in the right-hand position is the 1 space, then 2, then 4, and then 8. And so you can basically turn on all the possible combinations with those values. So you can see all the possible combinations here, 0 through F hexadecimal. Let's take a look at one row, 2 blocks, to see how the shorthand code works. Okay, so left block, right block. Any row, dot code shorthand. So here we have, let me scroll up a little bit so we can see everything together. So the left block is 0, 1, 0, 1, and that's a 5 right here, this row. So 5. The right block is 1, 0, 1, 1. 1, 0, 1, 1, and that is B in hexadecimal, so that row is 5B. The shorthand codes for an entire grid can be determined block by block just by converting the on-off conditions of each row. The following example provides a translation of an entire grid into the shorthand code. And we could scroll up and check these one at a time, but on the left block we have, in fact, we'll do a couple just so you can see how it works. We have 0, on, 0, 1, 1, 1, or off, on. So 0, 1, 1, 1. 0, 1, 1, 1, that is 7. And then on the right block we have 1, 1, 1, 0, and that is 1, 1, 1, 0, that's E. So that row is 7E. And row 2, let's just take a look for example. We have 1, 0, 1, 0. Let's see, which is right here, 1, 0, 1, 0. So that is A. That's what we see here, A. And then we have 0, 1, 0, 1, which is 5 right here, 0, 1, 0, 1, so that whole row is A5. So basically we take the left-hand block and the right-hand block, figure out the code for each row, put all those codes together, and we get the string for the entire character in hexadecimal. Okay? So we have the left-hand code block, the right-hand code block, you can see the arrows there, and all together you can see the string for the entire character. Therefore, if we want to define a character shaped as the X's on the grid indicate, we enter all the shorthand codes of the blocks as a single string. I'm not going to read, I guess I could read it. 7EA5819981BD817E. In the shorthand code then, one number or letter represents a whole block, 4 dots on the grid. 2 letters and or numbers represent a whole row. Based on the table, if all the dots were in all the blocks were turned to be on, the shorthand code for this condition would be basically 16 Fs. 1 F for each block. This code may seem long since it represents all 16 blocks within the grid, but it is still shorter than trying to write down all 64 separate conditions dot by dot. Once you've decided which dots you want on and off and worked out the code, you're ready to use the call CHAR statement. It looks like this. Call CHAR, parenthesis, 33, code for the character you're redefining, comma, and then the string that turns the dots on and off. Let's try a simple program that redefines character code 33, or the exclamation mark, as a character with all the dots turned on. The new character is then printed in the center of the screen, giving you a chance to see exactly how big one of the individual print areas really is. Enter these lines. Okay. New, yeah, that's a new instance of TI Basic here. 10, call clear. Almost every TI Basic, 10, call clear, not 100. Almost every TI Basic program starts with that. 20, call, okay, here we have to be careful, 20, call, CHAR, and we're going to take character code, I think they said 33, 33, comma, and a string. And here we've got 16 Fs, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yep, so just be careful here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that is a solid 8 by 8 square in hexadecimal. Okay, 30, we're going to print that to the screen, or a string of them. 30, call VCHAR. 12, 16, and 33. Actually, just one. Let's It's row 12, column 16, character 33, and no repetitions, so just one by one. 40, go to 40, just hold it on the screen. What did I mess up here? 40, go to 40. That's weird. Oh, I accidentally got a 0 on there. That's what happened. Just a typo. Okay, so line 20, redefining this character, character number 33, we're going to redefine it to be a solid square. The string of shorthand codes, or hexadecimal representation of that character, new character 33 in the center of the screen, and line 40 just holds it on the screen until we break the program. Let's see if it says to run the program. Run the program and observe your newly defined character on the screen. Solid block character, all dots on. There we go. Boom. Solid block character, all dots on. So that you can experiment with other shorthand codes, let's edit the program. Type these new lines. Okay, 5 input shorthand. And we want to call that a string. 20, call CHAR. And we were using character number 33 and whatever a string is. The string, the hexadecimal string representing the character. And 40, go to 5. This time, when you run the program, you'll be asked to input the shorthand code for the character you are defining. Try the following examples. Okay, run. So shorthand. Here we go. A smaller number of Fs. 1, 2, 3, 4, 5, 6, 7. So 8 Fs. And we get a little rectangle on the screen. Top 32 dots are on. Same character as FFFF with a bunch of zeros. Basically just ignores the, just plugs in zeros if you end up with a string of shorter than 16 characters in length. When you stop the program by pressing clear, the character that you created changes back into the character from the standard character set. In this case, character code 33 is restored to an exclamation point, and that symbol appears near the center of the screen. So see, if I end the program, it changes back into an exclamation point. The redefined character just reverts back to its original value. Entering FFFF, in other words 8 Fs, is the same as entering FFFF, 00000000. That is, the CHR routine fills out the right side of the string variable with zeros when there are less than 16 characters in the string. Knowing this fact allows you to easily examine all the shorthand codes individually. Just enter 0, 1, and so on up to F at the input request. So enter just an F. All dots on the left block of row 1. Okay. So just a single F. And there we go. That's just 4 dots in a row, and everything else is turned off. Try different combinations of the shorthand code. See if you can generate any interesting characters. Then let's revise the program again to print more than just one of our redefined characters. Okay, so let's just enter some anything between 0 and F. So how about we just do one of everything? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's then A, B, C, D, E, F. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That's 16 characters. And we see we have a little representation of all 16 possible blocks. Okay. You know, we could define a character, or maybe we can come up and enter the character that we saw up here. Let's do it. Let's scroll up just a little bit. Let's enter this guy. 7E. 7E. And we have A5. 8199. BD. BD. 8170. So let's make sure we got them all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Did I miss one? I must have. Where did I miss one? Let's back up. How embarrassing. So we have 7E, A5, 8-1, 9-9. Oh, there we go. I see. Another 8-1. 8-1, BD, 8-1. See where I missed a line there. And 7E. Okay. And there's our little smiley face character. It's like a little Happy Mac from Apple. Doesn't it kind of look like a little Macintosh logo? Happy Mac or Sad Mac. Cute. All right, let's keep scrolling here. Try different combinations of the shorthand code. See if you can generate any interesting characters. Then let's revise the program again to print more than just one of our redefined characters. Enter these lines. 30 for I equals 1 to 4. For I equals 1 to 4. 40, call VCHAR. And let's have 12. I plus 13. 33 and 4. So that's row 12, column I plus 13, 33 is the character code, and 4 is the number of repetitions vertically. 50, next I. And 60, go to 5. Go to, yeah, 5. So double check. Now list the program to see the changes. List. Okay, 5 input shorthand, 10 call clear, 20, that looks good, 30 for I equals 1 4, 40 the call for the CHAR statement, 50 go to, oh wait, I missed a line, 50 next I, 60 go to 5. Yeah, sorry about that. Getting ahead of myself. When you run the program and enter a shorthand code for a new character, that character is displayed 16 times in the center of the screen. The 16 characters appear in a square 4 characters wide by 4 characters high. Try the following. Enter FF. Okay, I'll run FF. There we go. End up with little lines repeated across the screen. A single print of the character with a shorthand code FF puts something like a long dash on the screen. Printing 4 of these characters side by side draws a line on the screen. To get dashes across the screen, you must leave a space by setting 2 dots in each block off. To do this, the code is 33. So enter 33. There we go. And we have dashes on the screen. 8 dashes per line. 1, 2, 3, 4, 5, 6, 7, 8. Notice that when you stop the program, the center of the screen fills with 16 exclamation points. Let's do that. There we go, 16 exclamation points now. Now enter some other codes and experiment with the program until you feel comfortable with the shorthand codes. To help you work out the codes, draw up several 8x8 grids and mark off your dots on, dots off design, then figure out the code you need for each block out of the grid. Now, I'm not going to take the time to do that right now, but just to reiterate, scroll up here. Maybe we'll do a separate video just designing some characters, but basically take a grid, an 8x8 grid, fill in some blocks, leave some blocks blank, then find the corresponding character code for each block of 4 characters, put them all together and get this long 16-digit hexadecimal string. And that will be your character code. Okay, I'm going to scroll down to where we were. Okay, a block figure with call CHAR. Now that you've had some experience with defining your own characters, let's see if we can create a small human figure by turning dots on and off. To begin, you'll need to create the figure on a character grid worksheet, like the one below. Later, when you're creating your own characters, you may want to make copies of the worksheet, not only to design your symbols, but also to use in translating the symbol into the shorthand code of the call CHAR statement. here's a CHAR worksheet. And now that I've been working in Pico 8 designing some retro games, this would be a fun little program to create in Pico 8, a little character creation program for TI-99. That'd be fun. Okay, so yeah, you basically fill in your, in fact, I might even make a printable resource for this or something, but you basically fill in your character, some dots on, some dots off, figure out the code for each block, get the hexadecimal code, and put them all together to get your character code. Piece of cake. Using the worksheet, we'll mark ones in the positions where the dots will be turned on. Okay, so this looks like a little human, a little head and 2 arms, big square body, and a couple legs sticking down below. Now let's look at the same figure with the on dot shaded in. Let's fill in the shorthand codes for developing the character. This form of the worksheet shows you what the character will look like on the screen. So here we go. You can see an example of this in action. We've got our little human figure. And so here is, in row 1, the left block is 1, 0, 0, 1. So we find the 1, 0, 0, 1 basically the binary code. And that translates to 9 in hexadecimal. And here we are, 9. And then the right block is the same. So we have 9 and 9. Row 2, we have 0, 1, 0, 1. So we find that 0, 1, 0, 1. That is the binary value. That's 5 in hexadecimal. So 5. And then on the right block, 1, 0, 1, 0. 1, 0, 1, 0. That's an A. So we have 5A for that row. So on and so forth. Rinse, repeat. And we get this long string for the hexadecimal code for that character. By filling in the worksheet for both the character and the shorthand codes, we know that one line of our program will be let A string equal this long hexadecimal string, 995, A3, C3, 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 C2, 424. Before we actually start our program, we need to discuss a bit further the process of defining a character. In our previous examples, we redefined an already existing character, the exclamation point, or character code 33. There are other character codes, however, that are undefined by the computer. These are available for you to use in building a customized character set in your graphics programs. The undefined character codes are grouped into the following sets for color graphics. So set 13 is character 128 through 135, set 14 is character 136 through 143, set 15 is character 144 through 151, and set 16 is 152 through 159. These extra character codes allow you to design special graphics characters for use in your own programs without giving up the standard keyboard characters. For example, you might want to design differently colored underline characters to highlight certain parts of a displayed message, or develop a game board on the screen with directions displayed in standard text characters. These codes and their corresponding set numbers are used in the call CHAR, call HCHAR, call VCHAR, and call color statements exactly as we use the defined character codes and their set numbers. Let's use code 128 in our sample program. Okay, we're ready to begin our program. Enter these lines. So let's clear the computer's memory here. 10, call clear. 20, here's our character string, which we have to be really careful. Let a string equal, okay, so we'll go slowly here, 995A, 995A, 3C, 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 let's see, 3C, 3, then we have 3C, 3C again, 3C, 3C, very easy to make typos, 24, 24, 24, 24. Okay, 30, call CHAR. So basically redefining character number 128 to be this string that we defined with the variable a string. Okay, 40, call color. I change the color of that character set containing that string, 13, 2, 16. And you can see the explanation bubble here. We've got the set number 13, for black foreground and white background. Okay, 50, call VCHAR. So it's going to draw it to the screen, VCHAR. 12, 16, 128. Row 12, column 16, and character 128, the new character that we defined. And 60, go to 60, that just holds it on the screen until we break the program. Okay, so again, let's look at the explanation bubbles. The shorthand code for our figure, quote figure, define character code 128. We've got set number, black and white. Character codes are black and white for the foreground and background colors. Call VCHR displays the character. Row number 12, column 16, character number 128, and then a holding pattern to keep it on the screen. So let's run. There we go. There's our little character on the screen. Little block figure on a white background. Okay. Now run the program and observe the small quote person on the screen. Remember, the figure is only one character in size, so look closely. When you're ready to stop the program, press clear. Would it be possible to animate our little figure? Yes, it would. By changing our program and incorporating one of the techniques we covered under animation, we can turn our character into Mr. Bojangles, the Dancing Man. It's my favorite little program from this chapter, Mr. Bojangles. Okay, so let's break the program. And notice it doesn't revert anything because we didn't replace an existing character, we defined a new character, and that just stays on the screen. Okay, Mr. Bojangles. As it's written presently, our program defines only one character. To make Mr. Bojangles appear to move, we need to define two characters that are alternately displayed in the same position. So we'll go to our CHAR worksheets to design our two new characters. Okay. So we've got, see, this is basically the same character with a leg kind of outstretched. And we've got the hexadecimal code. I'm not going to run through this, but you get the idea. You can pause the video if you're watching this after the fact on YouTube, and you can see how the blocks correspond to these row codes, which are all put together into this hexadecimal code for the character as a whole. And now we have the second figure. The other leg is outstretched, so he's dancing around. But I think there's some changes to the arms too, right? Yeah, the arms are kind of doing a little quasi-jumping jack here. And here's the character code for that version of the character. Now we're ready to edit the program. Enter these lines, okay? 20, we have to go slowly here. A string equals 995A 3C 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 3C. Okay, so 3C 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 4484. 4484, end quotes. Okay, 25, B string equals 1899, 1899, FF, 3C, 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 2221. Perfect. Okay, 35, call CHAR. And we're going to define the second version as character 129 now. 129 is B string. B string. 60 for delay equals 1 to 100. $70, next delay. This is a time delay loop. 80, call VCHAR. Oops. $12, 16, and 129, so it draws the second character to the screen, the same position. Okay, then another delay. 90 for delay equals 1 to 100. 100, next delay. And 110, go to 50. let's look at the explanation bubbles before we run the program. So line 20 is the first character. Line 25 is the second character, which are called A string and B string respectively. Line 35 defines character number 129 as B string. Line 60 and 70 display the first figure. It basically draws the screen. The character is being drawn to the screen, and then the character is delayed for a certain amount of time on the screen. Then we draw the second character to the screen, same delay, and then we loop backwards, rinse and repeat. Return and display the first character, repeating the whole procedure. Clear the screen and list the change program so that you can see how it fits together. So call clear list. Okay. Shouldn't be any errors, but kind of just give it a skim at least, make sure we're in the right ballpark. Now run the program and watch Mr. Bojangles dance. To stop the program, press clear. Okay, run. Mr. Bojangles is dancing. Check him out. All right. I remember just being so amused by this when I was a kid. It's my favorite little sample program in the TI, from this book anyway. Okay, Mr. Bojangles is dancing. Okay. Experiment. After running the program a few times, you might like to add a for next loop to make Mr. Bojangles dance across the screen. See page 107 for an example of this technique. Also try creating other pairs of characters and placing their shorthand codes in lines 20 and 25. Can you turn Mr. Bojangles into an acrobat who flips from his hands to his feet and back again? I would love to spend time doing that. I don't think I really have time to do that right now, but maybe I'll circle back and do some of these kind of like meta examples. Let's see if we can make him dance across the screen, though. That would be fun. At least do that part. So let's see. We've got the strings for the two characters. We've got the characters being defined in line 30 and 35. Got the color being set in line 40. Line 50 is where the character is being displayed to the screen. So I think what we need to do is create a loop. So let's do something like line 45 for I equals 3 to 28. Or maybe it's 32, I can't remember. We'll figure it out. And then let's do let me think where the best place to end the loop is here. $110 next. Replacing that go-to statement with next I. Let's list it out. I think when the character reaches, oh, we need to change the printing of the character on the screen. So we need line. Let's do 50. Call BCHAR. Row 12, column I. And 128. But when it prints the next character, on line 80, we need to make sure it's I plus 1, right? We need to move one space to the right. I think that should do it. Let's run it. Is it going to walk across the screen? Oh, just not clearing the screen. That's right. We've got to remember to clear the screen. Actually, I see another problem here as well. List. We need to let's add a call clear statement on line 75. Let's see what effect that has. Okay, I'm getting there. Not quite what I wanted. We need to clear the screen before 46. Call clear. Let's see if this is an improvement. Okay, what I can't figure out. Oh, when it loops back, it goes. It basically adds 1 to I. But that's the same as I plus 1. So let's see, what can we do to fix this? What changes can we make here? So I think we're on the right track with the loop that we've got. This is going to be kind of a wacky program, but let's see if we can make it happen anyway. I've got a little bit of time. So let's we need to add a loop that alternates between the two. Let's see, for character equals. No, I don't want to do that. Yeah, okay. Okay, this is going to be a bit of a. I'm not sure this is the most efficient way to do this, but I think we can probably figure it out. So we're going to have a variable called character. So let's do line 26. No, 36. Character equals a string. Let's list it out. And then what we're going to do, we are going to add an if-then statement. If character equals well, let me think here. How do I want to do this? Character equals. Where do I want to put it? I want to delete some of these additions I made. I think I'm making this too hard. Let's delete 46. Okay. Let's delete 50. Let's delete 60. 70. 80, 90, and 110. We're going to simplify this a little bit. Okay. So let's go with line 50. If character equals a string, then let's just go up to, like, I don't know, line 300. 300, what are we going to do? We're going to do call BCHAR uh, 12, 6, oh, actually 12, I, and then character. Then we'll have a little time delay. For delay, oops, line 310. For delay equals typo, 1 to 100. 320. Next delay, 330. We're going to go back to line 60. Go to line 60. 60, if character equals B string, then 400. Oh, actually, I saw what I need. We need to, after we do the time delay, typo, 320, next delay, 330, go do 60. We need to do 325 character equals, we need to change it to B string. Okay, so let's list it out again. Okay, so 400, call BCHAR, 12, I, character, 410, for delay, equals 1 to 100. Hope I can get this working. It's been a long time since I've done programmed in TI Basic. 420, next delay, 425, character equals B string, change it back to B string, I'll change it back to A string, and let's see, 430, go to let's see, maybe we can go to line 70, and then we can have 70 be next I think. Let's list it out. Ooh, list. Okay, so we've got our two characters being defined. We first of all say the new variable character is the A string version of the character. Set the color. Lines 45 through 70 are loops. So for I equals 3 through 28, if character equals A string, then 300. We go to line 300, print the character, set a delay, change the character. We need to clear the screen a couple places. So I think what we need to do is, before we draw each character, we need to clear the screen. So like, Yeah, I think what we need to do is actually clear the screen before we draw each character. So 300 call clear, 305 call VCHAR, 12 comma I comma character, and 400 call clear, and 405 call VCHAR, 12 comma I comma character. I think this will do it. Let's see what happens. Oh, 4 next and 100. Next delay. Look at list. Oh yeah, we have the delay. Okay, so we can get rid of next delay. So 100 can go away. List. So we move the delay into the subroutines here. Run. String number mismatch in 36. Oh yeah, it's got to be a string, right? Character string equals a string. Okay, 36 character. I see what I did there. Character string equals a string. Okay, so we need to retype these lines that use character without the string on to include the string. So let's do these one at a time. The next one on the list here, I'm sort of just pointing on the screen here. 305 call VCHAR, 12 comma I comma character string. Okay. Then we have 325 character string equals B string, and 405 call VCHAR, 12 comma I comma character string, and 425 character string equals a string. Okay, run. See how we did here. I missed one. Must have. 50. Oh, yep. 50 and 60. 50. If character string equals a string, then 300. 60. If character string equals B string, then 400. Run. 305. Did I miss one again? How many can I miss here? 305. Okay, why doesn't it like that? Run. String number mismatch in 305. Okay. Why is there a mismatch? So in line 36, we have character string equals a string. Should be fine. 36, character string. Okay. If character string equals a string, then 300. Go to line 300. Call VCHAR 12 comma I comma character string. Totally confused why that wouldn't work. Unless it doesn't like the string being defined as another string. Might be trying to turn it into a number, but that's weird. String number mismatch in 305. Oh, I know what's happening. Aha, I know. Okay, I see what it is. That doesn't need to be a string. That's the character code. Got it. Yeah. I see what mistake I made. CHAR. So if it's a string, that's going to be 128. Yep. Okay. So 12, comma I, comma 128. There we go. And on, let's see, 405, call CHAR 12, comma I, comma 129. Okay. Yeah. Let's do. So what I was hoping is that when he changes positions, he would move. So what did I do wrong here? Yeah, I think I just structured this wrong, where what I was hoping is that would, every loop, it would change the So let's see, how would I do this? I'm gonna have to put a pin in this one. I hate to be defeated, but I got dinner coming in a little bit, and I gotta. I'm gonna return to this. I'm gonna do a separate video just on this. So sorry about that. If you're hoping to see it work properly, I'm not gonna be able to do it right this second, but I will work on it because it's so much fun. Okay, as we've mentioned, Mr. Bojangles is pretty small, only one character in size. Not all the designs you can create are limited to this small size. You can combine several small characters to construct bigger graphics that cover more of the screen. Our next program shows how to design a larger graphic using one small color character as our building block. Okay, the giant. Okay, so we're going to clear the computer's memory here. I will return to this. I want to do a separate video just on making Mr. Bojangles dance. Okay, dance across the screen. What I was hoping is that when it would move, it would immediately change the sprite number, and I'm having a hard time figuring out how to do that. But I will figure it out. Okay, the giant. New. Okay, if you define one special character where all the dots are on, you can then use it to paint in the rest of a large figure. The following program takes the small character just mentioned and creates a giant figure similar to the Mr. Bojangles character. Enter the program and see what it does. Okay. Let's do it. 10, call, clear. 20, a string equals, got to be careful here. Okay, yeah, it's all F's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 30, call CHAR. Yeah, I think I was trying to make that previous program too complicated. I'll come back and give it another go. 128, comma a string, but not tonight. 40, call color. Oops. Let's see, 13, comma 5, comma 5. Okay, here we have to be careful here. Build the head and center of torso. It reminds me of like Voltron. Oh, form the head. Okay. 50, call VCHAR. Form arms and legs. Boom. 7, 15, 128, and 8. 7, 15, 128, and 8. 60, call VCHAR. 7, 16, 128, and 8. 7, 16, 128, and 8. 70, call VCHAR. 9, 14, 128, and 10. 9, 14, 128, and 10. 80, call VCHAR. 9, 17, 128, and 10. 90, call VCHAR. 7, 12, 128, and 3. 7, 12, 128, and 3. Oops, sorry for the pop-up there. 100. Call VCHAR. 9, 13, and 128. 110. Call VCHAR. 9, 19, 128, and 3. 120. Call VCHAR. 9, 18, 128. Okay, and 130, go to 130, just holds the graphic on the screen. Okay, let's look at the explanation bubbles. Okay, shorthand code to turn all the dots on in the character. Line 40 sets the character color, dark blue foreground and background. Let's see, line 50 and 60 builds the head and center of torso. Line 70, left torso and leg. Line 80, right torso and leg. 90 and 100 are left arm. 110 and 120 are right arm. And then 130 holds the graphic on the screen. So run, we should get Mr. Bojangles here now. Check him out. And we could animate this so the whole thing dances. That would take a little longer. Not going to bother doing that right now, but I might come back and do some Mr. Bojangles streams here. When you run the program, you'll see a larger version of Mr. Bojangles. Giant Mr. Bojangles. I love it. Our dark blue giant is rather angular and blocky since it's created from a single angular character. You might like to rework the program, adding extra defined characters that allow you to soften the edges of the figure. Experiment with some other block designs using your all dots on character, then try defining other characters to include in your graphics programs. The example shown below will help you get started. So we've got a little triangle, we've got a little diamond shape, little like an hourglass figure. Okay, so we'll do some experimenting another time. I have to get ready for dinner, but I do want to come back and try to fix my Mr. Bojangles program. I'm embarrassed I couldn't fix that out on the fly, but I will fix it. In a future video, it'll be fun. Summary of Chapter 5. Chapter 5 is dealt entirely with computer graphics, the colorful patterns and designs you can create with your computer. Only 2 new statements have been introduced. Call Screen allows you to change the run mode screen to any color you choose, and Call CHAR defines a character code for a character you create. In addition to these 2 statements, you've experimented with the following techniques: creating large color blocks on the screen, making patterns and designs from standard colors, animating your graphics, and creating your own characters by turning dots on and off. The ability to create color graphics can add a lot of excitement to your computer programming. We hope that you've enjoyed this introduction to graphics and that you'll find even more creative ways to use your computer. This chapter concludes our introductory tour through the TI basic language. You are now well launched into your programming career. For more advanced features, you may want to consult the basic reference section of the user's reference guide. Here are some sections we suggest. Additional editing techniques, see Edit. Automatic line numbering, see Number. Break, Trace. Recording programs on the TI disk memory system or cassette tape recorder, see Save and Old. If you'd like to consult a programming book on an intermediate level, We can recommend an excellent one, Herbert Peckham's Programming Basic with a TI Home Computer from New York McGraw-Hill Book Company, 1979, a mere 46 years ago. You'll find a coupon for ordering this book on page 143. Congratulations and best wishes for continued success in basic programming. And so what I'm going to do, there's some appendices here. I'm not going to cover the appendices now, but I think I'm going to do a separate video looking at the appendices. And then I'm going to come back and do another stream where I try to do two things. One, I want to fix my little miniature, the small program where the miniature Mr. Bojangles dances across the screen. I want to fix that. And maybe I'll write another program that makes giant Mr. Bojangles dance. That might be a lot of fun as well. So I'll do those in a future video. But in the meantime, thanks for tuning in to Chapter 5 of Beginner's Basic for the Texas Instruments TI-99 4A home computer, my favorite chapter of my favorite Introduction to Programming book on my favorite retro computer system. I hope you enjoyed it, and take care. Remember to like and subscribe on YouTube if you're watching this on YouTube, and if you're on Twitch, I'd appreciate a subscription or a follow or a shout out, and anything you can do. We're trying to grow our stream, doing some combination of World of Warcraft streaming and retro gaming streaming and some programming streaming. So thanks for tuning in, anyone who's still watching. I really appreciate it. Have a good evening. Take care now.